Hello! Now, today we are going to be looking at multiplication and division and how they relate to each other. So that's our job for today. Now we already know how to multiply numbers. We've been doing it for years. In secondary school, we will sometimes call multiplying two numbers together the product of two numbers. So that's another way that we can call multiplication. We can say that it's the product of two numbers. So the product of 3 and 2 would be 6. Now, before now, we might have used an x for our multiply symbol. So 3 by 2 would be 6. In secondary school, we're going to try and avoid using x for multiply. There's a very good reason for that, because x is going to mean a letter, is going to mean the letter x, as in from the alphabet XYZ, when we are doing algebra. It's a very, very common letter that we use, and to avoid confusion, we try to avoid using x for multiply because it has another meaning that we're going to need later on. Likewise with division, you would have seen a sum 12 divide 3, and we would say that that was 4. In secondary school, we're going to tend to write our division as a fraction. So it means exactly the same thing. How many 3's are there in 12? There are 4 of them. How many 3's are there in 12? There are 4 of them. It's the same thing, but we write it in a slightly different way because the problems we try and solve in secondary school are more advanced, and often it's more useful to write it in this form. So we need to be writing it in that form so we're prepared for when things get more complicated. But let's jump back into multiplication and do an example. The first way that we can do multiplication, if we take our example that we've already written, 3 by 2, we can think of that as having 3 2's added together. Now we're familiar with this idea likely already. If we're not, we need to be paying lots of attention so that we get it. We could say that we have 3 2's. So that would be 2 plus 2 plus 2. We have 3 2's. So 2 plus 2 is 4 and 2 is 6. We could also have 3 by 2, and we could say that that meant that we had 2 3's. So we could say that we had 2 3's and add them together. 3 plus 3 would also equal 6. And on our number line, we can keep track of the same thing. If we had 3 2's, we'd say we'd have 1 2, 2 2's, and 3 2's, and that would give us 6. Or on our number line, we could say that if we had 2 3's, so we'd have 1 3 and 2 3's. And both ways are valid ways of looking at multiplication, that they're ways of grouping things together. So we have a group of 3 2's, or we have a group of 2 3's, and both are perfectly accurate to say. So this way of using our number line to count up how many groups of numbers we've got is one way of looking at multiplication, and it can be helpful for picturing when we're trying to solve a problem. Another really useful tool is to look at if we want to try and figure out the size of a field. So if we imagine that we're out in the countryside and we've got a field and we want to figure out the area of the field, and our field is broken up into 4 sections. One bit of the field down to our first fence is 3 meters long. The second part of that side of the field is 7 meters long. And then on the other side, we have a rectangular field. The width side, we have a section that's 3 meters long and 5 meters long. How would I find out the area of each one of these smaller fields? Well, I know how to get the area of rectangles, don't I? I know that at the area of my rectangles, so the area of rectangles is going to be the length by the width. So the length by the width. So to get the area of each of my smaller fields, I would have the length multiplied by the width. So I'd have 3 multiplied by 3 would give me 9. And here, what must be the length of this bit of the fence? Well, if this is a rectangular field, then that means that this length here must be the same as this length here. It must be 3. So that means that my length by my width, going to be 3 by 7, is going to equal 21. So now I found the area of my first bit of the field and the second bit of the field. I can do the same thing here. What must be the length here? I have 5. And what must the length in here be? It must be the same as my length up here. It must be 3 as well. So I'll have 5 by 3 is going to give me 15. And lastly, I have this one on here, and I have to figure out what both sides of this one are. So this length must be the same as this length for a rectangle. So that's going to be 7. And this length must be the same as my 5 over here. So that's going to be 5. So I'm going to have 5 multiplied by 7. I know from my times table is going to give me 35. Now I know the area of each little piece of my field. Now how could I use that to find the area of my big field altogether? I could add up the area of this field, this little field, plus this little field, plus this little field, plus this little field, and in total I would have to get the area of my big field. So what I can do is I can add up my area for my first little field. So the area is going to equal 9 plus 21 plus 15 plus 35. I can add up all those together, and I'm going to add them each stage by stage. So I have 9 plus 21 is going to give me 30. So that becomes 30 plus 15 plus 35. Now I'm going to be adding 30 plus 15. So I get 45 plus 35. Now I can add them together and I get 80 for my overall area. So I have my overall field, the whole field is 80 meters squared. We're going to come back to units in a little while, but if all of these were in meters, our area would be in meters squared. And you're going to look at that in science as well. So our area would be in meters squared. So that's how we can find the area of smaller pieces of my rectangle, and I can use that to find the area of my bigger rectangle. Now let's see if we can do that in reverse. So we have this rectangle down here, and we have one side length is 12 and the other is 7. Now 12 and 7 are complicated numbers to multiply. Could we break them up into easier pieces to work with? I think we could. So there's a few different options that we have, but probably the easiest one for 12 would be to break it up into 10 plus 2. So if I break this length here into a length that's 2 and a length that's 10, because 2 plus 10 is 12. So I can break up that overall length into 2 plus 10. And likewise, 7 is an awkward number to multiply, so I could break that up into 2 plus 5. 2 plus 5. 2 plus 5 is 7. So if I imagine that I have a piece of paper, so we have our copybook in front of us and we have it open. I have the top of my copybook and the sides of my copybook, and I'm able to use my ruler, and I'd be able to break up my copybook into, we'll say, 2 centimeters and 10 centimeters if a copybook when it was opened up was 12 centimeters across. And the side of my copybook, if it was 7 centimeters long, I could break it into 2 centimeters and 5 centimeters. I could do that with my ruler. I could measure 2 centimeters down from the top, and I'd be able to break it up into 2 centimeter and 5 centimeter lengths. Now I'm in a position to multiply nicer numbers. 2 and 10 and 2 and 5 are nicer numbers, easier numbers to multiply than 12 and 7. Now, as I've said before, the real reason we're doing this is to prepare us for work that we're going to do later on. So if you find this a little bit confusing, I still want you working on it, because this is going to be really important for understanding algebra later on in the year, and we're preparing ourselves for the harder work we're going to do later. So the area here is going to be 2 by 2 is going to be 4. Here is going to be 2 by 10 is going to be 20. Here's going to be a 2 by 5 is going to be 10. And here's going to be 5 by 10 is going to be 50. Now if I know the area of each one of these little pieces of my rectangle, I can add up all of them. 4 plus 10 plus 20 plus 50. I add my first two and I get 14 plus 20 plus 50. 14 plus 20, I'm going to get 34 plus 50, and add them together and I get 84. Again, if we had units here, if I said that this was my copybook and these were all in centimeters, as in the markings on your ruler, we would end up with 84 centimeters squared. So that's our idea for multiplication. Division works exactly the same way as you're already familiar with. So if we have a number like 16 and we divide it by 8, that's going to give us 2. What are we asking? How many 8s are there in 16? The way you might be more familiar with writing that would be 16 divide 8 is equal to 2. That's perfectly valid. It's true that you can write it that way. This is the way we're going to need to write it in the long run. So that's what we need to be practicing. Likewise, 20 divided by 5 would be 4. There are 4 5s in 20. How many 5s are there in 20? There are 4. Now, a quick note. We talked when we were talking about addition and subtraction about the idea that addition is the inverse, is the undoing of subtraction. And it turns out that multiply is the inverse of divide. So if I had 12 divided by 3, I would get 4. And if I then took 4 and I multiplied it by 3, I would get back to 12. So multiplying has undone what I did with division. So it is the inverse of it. And again, this idea of inverse is going to be very important when we come on to the maths of triangles later on in our work in maths. So we've looked at how it is we can multiply using our number line. We've looked at this very important idea of using area of fields or areas of our copy to to multiply. We've reminded ourselves of division, and we know that multiply is the inverse, is the undoing of division, and vice versa. And that's what we need for now.